So our next speaker, he travels from Düsseldorf, Germany, and he's a software engineer for Trivago. So basically, he's working on making our holidays better. And I think he deserves another round of applause, right, for that. We all love holidays. So please welcome Andy. He's going to talk about all the issues and the journey of Trivago in putting Redis in production. Welcome.
Hi, everybody. Before I start, two things. So first, please make a big, big applause for all former speakers up to here. I think they make a really, really great job so far. And the second topic, I think we all need to talk to Hugo about the pizza and pineapple thingy again, because I thought French people has a good taste for food, but I might be wrong. So, learn Redis the hard way in production. I will tell you a short story how you should not run your Redis infrastructure, or what kind of failures we learned and had collected over the last few years. So, my name's Andy. Oh, wrong picture, sorry. I work for Trivago, as mentioned before. I'm doing it in the site reliability and platform engineering group. So, my job is taking everything up and running that the product teams can use it without hassle. If you travel to Düsseldorf, feel free to drop by. I'm the organizer of the Web Engineering Meetup Düsseldorf, so drop by and say hello. Let's start with the main topic, Redis. Who knows Redis? Oh, good one, a few hands. Who uses Redis in production? Few hands as well. And now the final question, who have or had issues in the past with Redis in production? Ah, a few ones. That's good, I'm not alone. For those people who don't know what Redis is an in-memory data structure store. Typical use cases are use it as a normal database, as caching, or as a message broker. So many people raise, okay, Redis, great, in-memory data structure store, funny. But what is the difference to, for example, Memcache or other in-memory data structure stores? The fun here is Redis supports kind of native data types. So for example, strings, hashes, or hash maps, what is in PHP an array, lists, what is in PHP an array, sets, and guess what? It is an array in PHP. So, of course, next to the support of native data types, there are several other features like replication, different guarantees to persist data on disk, eviction policies, Lua scripting, etc., etc. To sum up, we're talking about a really, really sophisticated NoSQL database. But this was the introduction for the Redis itself. Let's come to the story. Could you remember when the movie Machete was shown in the cinemas the first time? Or The Social Network? Or Yogi Bear. So we are talking about December 2010 right now, but to be honest, it doesn't matter at all because our story starts a few months before. September 2010. We introduced Redis into our stack. Back in the days, our stack was mostly driven by PHP. And this is a commit, so if you are not familiar with PHP, back in 2010, we didn't have kind of dependency management. So dependency management was kind of, you create a cron folder and put some PHP files in it. Of course, now it has Composer, etc., and it looks a little bit different now. But in the end, it's the same, right? You put files into your project. Those two files served Trivago for quite some time. So we didn't have issues with it. So let's jump 3 years into the future. February 2013. We was a little bit bored, and we thought, okay, let's make our website a little bit faster. So what we did is we replaced a PHP library that takes care about the connection to Redis. It's called Redis, with an PHP extension that is written in C. So the reason was kind of simple. We had way faster website, so was able to deliver our website faster to the client. No issues at all, everything went fine, too fine for my purpose. But let's jump another year, February 2014. That's where the story kind of really starts. At February 2014, we launched several new features and added new language platforms. So we opened up new market. We launched our platform for trivago in Indonesia, Malaysia, Thailand, United Arab Emirates, South Africa, etc., etc. So all at once. The traffic grows quite quickly because our marketing department was running TV spots like crazy and internet ad like crazy. So for a typical website, you have two possibilities. First, everything went well, or second, you do this one. This happened, and this happened quite often. Around about 40% of our requests were answered by 500. This is quite a lot, and if you think about a business perspective, what? 40%? Really? You're kidding me. That means that 40% of our revenue goes down, or 40% of the users sees this. This is not 100% true. Modern single-page applications fire a lot of AJAX requests. They're running asynchronously, they implement some kind of polling, etc., etc. So that is what we did as well. So that's the reason 40% of our requests answered an HTTP 500. But this does not mean that every user was seeing of HTTP 500. Of course, expect we are all surfing with an open developer console, right? We see those HTTP 500s. Anyhow, this is how it looks like in the front end. In the back end, we have a typical stack trace from PHP. This is a kind of shortened stack trace. And here you see 3-4 years later, we were switched to the Symfony framework. It's a quite popular PHP framework. And that has proper dependency management as well. So these kind of stack traces we have written in several hundred gigabytes per day. So because 40% of our requests fail, and every request logs a bigger stack trace with 19 or more steps. This is kind of shortened stack trace, but the important part is here the read error on connection issue on the top that is marked as bold. I mean, we are not different. If you see an error, what you do? Of course, you Google. And we had a lot of good results. I mean, the first one is the best one, right? It's a GitHub issue. It's for our PHP extension. We thought, great, this problem is solved within 5 minutes. Yeah, that's the problem here. We have read it and detected that the issue doesn't seem to be easy to solve. This screenshot here is a few days old, so around about 5 days. This issue was opened 2011. This issue is still open, and this issue has 123 comments. This is not what you want to see when the management is in your bag when 40% of your requests fail. In this issue, there are many different architectures, many different operating systems, many different ways how to solve this issue. And we tried them all. Here are a few of them. Just to keep it short, we raised the PHP connection timeout from our PHP stack to the Redis server from 500 milliseconds to 2.5 seconds. After this doesn't work, we disabled the timeout problem at all, so it ran in undefined. We modified parts of the operating system, like disabling Zyn cookies for the network stack, checking the numbers of file descriptors on our Redis server, web servers, etc., raising the M buffer of the TCP IC stack, or control and adjust the TCP backlog sizes when new connections comes in. What the fuck? I mean, we are all kind of reading a lot about microservices and what we have to take into consideration when launching, programming microservices, etc., etc. And when you read about microservices, you read a lot about timeouts, correct setting of timeouts, circuit breakers, etc., etc. And when you compare these kind of solutions to the current world, fuck, what we did, this was kind of really, really, really dangerous. I mean, we disabled timeouts at all. Means you visit a website and your website can run for 10, 12, 15 seconds because we tried to open up a connection to a Redis server. Anyhow, we didn't know what we did, so the result was not very good. So we summed it up at sometimes you have a good day and sometimes you have a bad day while debugging. But we had no choice. We had to continue. So in February 2014, we got back to our code base and checked in detail, okay, what we are doing there. We discovered that we were not able, or that we opened a Redis connection in PHP, but didn't close it. Modern programming language say, yeah, so what? The problem with PHP, in former versions of PHP, if you open up a MySQL connection and didn't close it, you had a kind of memory leaks in it because you have dangling MySQL connections running around. And with a website with a lot of traffic, this can sum up your memory of your server, and your server's gone. So we fixed it. We closed the Redis connection at the end of the web request. Okay, I mean, nothing changed. We considered it as a kind of Boy Scout rule, so leaving the place better than you got into it. So we asked us, okay, what is the real issue? Do we have an issue on the client side, so on the web server side, or do we have an issue on the server side, on the Redis side? So we need to start with something. What we did is we did an A/B testing of connection libraries. You remember, starting from the talk, I said, okay, we exchanged a PHP library to connecting with Redis with a C implementation, a PXP extension, to connect to Redis. And now we switch it back. For 50% of our servers, we deployed a version where we implemented the PHP connection library again. And for 50% of our servers, we keep it as usual. We're running the PHP extension written in C. This was our way to identify is it a client or a server issue. The fun part is we saw the same error, but in a different wording. Okay, bad. Then we said, okay, great, it must be a server issue. We upgraded Redis. Why we upgraded Redis? What the fuck? I mean, if I would open an issue on GitHub, and of course I provide as much detail as possible, the open source maintainer will ask me, okay, Redis you're running, and I would say, yeah, Redis version 2.6, and 2.8 is out. What would be the first answer of the open source maintainer? Can you please upgrade? To save this step, we did an upgrade, so quite some time. You see February, March, May, upgrade a big installation is not as easy as thought, but no, nothing has changed. So we have spent around about 3 months for learning. I mean, we did experiments, right? And if you do experiments, you have a success when you know a way how is not what's working, right? So we had a success, but we didn't find a solution. At this point, we were really, really frustrated. 3 months were gone. We were not frustrated because we didn't solve the issue. We were frustrated because we didn't understand the issue at all. We don't know where the error come from. We don't know, okay, was it a client side? Was it a server side? What happened here? What is read error on connection? There was a GitHub issue with 120 comments and no one solved it, or they solved it all somehow. But I don't. So we didn't have a chance, and what we do, we start reading the documentation. Every proper software engineer would say, what? Okay, back to the whiteboard, read the complete documentation. We found 2 useful features, or where we thought it were useful. Those features are called watchdog and slow log. Those 2 features are debugging tools. They are designed to track those latency problems in Redis. Great. We found them and were really curious to test them out because we said, okay, great. If they are designed to track latency problems and we have some kind of read error on connection, they should tell us the solution. 21st of May, 2014, 6 p.m. in the evening. We found this and we wanted to try it. But we forgot one important employee, and I guess you know them all. It's called Murphy. Murphy's law is anything that can go wrong will go wrong. So 6 p.m. in the evening, most of the people are looking into walking home. We activated the watchdog feature and had a segmentation fault. So complete trivago offline. This is not something you want to see at 6 p.m. in the evening. So we had an issue, we were running in a Redis bug. So this bug was a real bug in Redis. The bug was we are running our Redis instances on a FreeBSD system, and FreeBSD operating system signals are kind of different from operating system signals from Linux. And the Redis has an issue with handling those operating system signals while Watchdog is active and Redis persists on disk. So a really kind of rare situation. The bug ticket of Redis was solved within 5 days, quite fast. So what is the first learning? Testing in production should be avoided. Just kidding. I mean, you don't learn it, right? The first learning was Redis is single-threaded. Every command will block for a certain time. People who are using Redis will say, yeah, man, this is obvoice. This is on the web page. It is the first sentence. True, but if you read GitHub issues, if you read mailing lists, if you read Reddit, if you read blog posts, etc., 90% of the issues come from this fact that Redis is single-threaded. So again, Redis is single-threaded. We will come to this in a few minutes. So we had a crashed Redis instance, masternode. So what you do in a company, you write a postmortem that other engineers can learn from it. While writing this postmortem, we analyzed the logs from what Redis is doing. And this is a small snippet about the logs. So you see that we have 10,000 changes within 60 seconds. So background saving started, etc., a few accepting client connections. But if you have a detailed look at it, why does it take 400 milliseconds to just start a process to back up data? 400 milliseconds. If you are in the web, 400 milliseconds is way too much time. Most studies say that humans recognize delay starting at 200 milliseconds. And we had a blocking instance for 400 milliseconds just to start a persistent process. And because Redis is single-threaded, during this time, we don't accept new connections to the Redis at all. If you dive deep into this behavior of Redis, this is kind of understandable. What Redis is doing is, because Redis is single-threaded, it forks out a second process. If you fork out a second process for dumping this data, the main process is still changing the data. So to persist all this data in the second process, you have to copy the memory page table. If you have a big Redis instance, the complete memory page table has to be copied. So if you have 5 keys, it is fine. If you have 5 trillion keys, this takes a while. There are reports out in the internet that said, okay, my background saving process, forking process, takes 2 seconds, 4 seconds. If you run on virtual hardware, like with VMware or Zen, it is even worse. So, second tip, review your persistence requirements. So at first, do you need persistence? Yes, no. Which kinds of persistence? Background saving or append-only file? How many minutes data loss you can accept, etc., etc. Redis is shipped with kind of sane defaults. And the sane defaults apply so-called save points. Save points are you define how many keys should be changed, so write operations, within a certain time. And if this is triggered, your data will be persisted. This is a typical big save thing. The problem is if you have more traffic, so you have more key modifications, you persist more often. So the problems will get more with traffic. To come up to a solution, people getting away from the save points, they deactivate it at all and fire a cron job with a biggie save command. Means if you are have traffic from Europe, you can persist your data during midnight or during 2 a.m. in the morning because most of the traffic is not there yet. Or people were setting up a dedicated Redis slave that receives no traffic but only has the persistence. So far, so good. A few problems were solved in Redis. We had a second big code base written in Java, and people and teams are using Redis. They say, yeah, Redis is great, awesome, it answers so fast, etc., etc. And Redis supports multiple databases per instance, like MySQL. So you can have a database 1 and a database 2 in one Redis instance. That's great. So it seems to be a really, really great idea to give team 1 database 1, team 2 database 2, team 3 database 3, etc., etc. The problem, Redis is single-threaded, and Redis is single-threaded even over databases. Means not every database is a single process. Means if team 3 make a lot of operations, you block team 1 and team 2. That's what happened in our case. Redis has a feature called pipelining. Pipelining is a feature where you can bundle 10,000 commands, 100,000 commands, and transfer this over the network to the Redis server once instead of having 100 network round trips. The problem is Redis will take care that these commands are taken down in order. Means if you have 100K commands that has a high time complexity, your Redis server is blocked for 5 minutes. Means all other teams can't access their Redis data. Tip 3, share your data contexts because they might block each other. So they have different use cases. The one is using Redis for a cache. The second one is using Redis for a complete normal database. The third one is using us as a message broker. Think about your bounded context. The select command is used to switch from one database to another. The creator of Redis said this is the first command he wanted to delete from Redis as well because he said it's an anti-pattern. Because so many people run exactly into this issue. And on the other side, Redis is single-threaded. Again, modern servers have 8, 16, 24 CPU cores. So it's no problem to run multiple Redis instances per server. The select feature is marked as an anti-pattern because, yeah. So my recommendation is launch multiple Redis instances per server. We keep around about running up to 16 Redis instances per server. 1 month later, we solved a lot of issues. We have way less pressure. But then the university comes back. Who knows the Bachmann-Landau notation? Not so many. Who knows the big O notation? Way more. The Bachmann-Landau was a mathematic. He invented these big O notation. Bachmann-Landau notation is the original name of it. For those who don't know, big O notation is a kind of notation to express the time complexity of an algorithm. Just an example, if you have a hash map and you want to access a key in a hash map, you have an O by 1 complexity. The reason is O by 1 because the time complexity is equal even if the hash map is growing. If you are searching a value in a list, you have to iterate over the complete list, and in the worst case, you will find your value at the last item or never. So it means if you have a list with 1 million items, your algorithm will take longer if you have a list with, instead of having a list with 5 items. That's the reason why searching an item in a list is O by n, where n is the number of items in the list. The fun part here is every Redis command has shown the time complexity in the documentation. This is great. Here, for example, the set is O by 1. We have a keys pattern that's O by n. And a keys pattern is typically what it says. You send keys, and Redis will return all keys that are stored into the database. That's great if you have an instance with 5 keys. That's really, really bad when you have an instance with 5 trillion keys. Right now, this is a screenshot of the documentation done a few days ago. There is right now a big warning. Warning, consider keys as a command should be only used in production environment with extreme care. This warning was not there in 2014. Guess what? We had a cron job. In the last corner of our data center, there was a shitload of dust on this server already. And this cron job was fired every 5 minutes. And every 5 minutes, it fires a keys to our main Redis database that has, whatever, 50 million keys. So Redis was blocking for around about 5 seconds every 5 minutes. So you see all these log rotations, and it takes days up to the point where we found this server with this cron job. So please consider or check the time complexity of the command. High big O estimations can slow performance. But now you say, hey, but I need all keys from my database. That's fine. For most of the heavy, expensive commands like keys, there are replacements like the scan family. The scan family works nearly the same as a keys command, only with the difference that you say how many keys you want to get back, plus you get a pointer back where you can continue the search, like a typical paging operation in a blog or in a shop. August 2014. Many issues were solved. Website is online again. Our traffic grew and grew due to more advertisement and new language platforms. And when this happens, you start to scale your stack. In a typical web application, this looks like this. You have the big internet on the top. You have a bunch of web servers. And you have a Redis server or n Redis servers. In our frontend, we run PHP. PHP is a stateless language, and at this time we were running Apache 2 with a pre-fork model, so no Nginx with FPM or something. In this environment, a typical PHP request looks like an HTTP request comes in, the application creates a connection to Redis. The operation now executed, say, hi, give me a key, yeah, just thank you, I'm fine. Application will close the connection and return the content to the client. This is fine if you have 5 web servers, but I said we need to scale our stack. So what we have done is we added a bunch of web servers next to each other. So we grow from 5 to 10 to 20 to 15 to 60 to 80. But we didn't scale the backend. This is not good because imagine you have around about 200 clients per server. 200 multiplied by 5 means, okay, 1,000 connections on the Redis server. So you scale your web servers up to 80. Means 80 multiplied by 200. But you didn't scale the backend. Means your Redis server is kind of under heavy load. We didn't have these kind of persistent connections that you can apply with Nginx and FPM model because we have the worker, and the worker had a number of requests, and after this, the worker died of Apache and was forked again. So our Redis server was kind of busy and was not able to answer anymore because it has to take care about hello, one command, bye-bye. Hello, one command, bye-bye. So it was busy with connecting exceptions, with accepting connections, sorry. We searched a little bit around and found that Twitter had the same problem back in the days. They wrote a kind of proxy called proxy, and this proxy is installed on every web server. This proxy is written in C, so it's a stateless process. You start it, and it runs forever. Your PHP application only connects to localhost via Unix domain socket. The proxy has a stateful connection to the Redis server. What does it mean now? So first, if you introduce this, the CPU usage of Redis will drop immediately because it don't have to take care about the accepting connection handling anymore. You have way faster connection handling, so your connection overhead will be reduced, which leads to, in our case, 50 milliseconds save in the front end, because not every PHP process has to connect to Redis anymore, because the proxy has already a connection, so we connect only to the local. And the way better advantage is we are running a kind of big team, around about 100, 150 people working on these kind of code bases. And with 100, 150 engineers, you have problems with knowledge, because not everyone is a really expert in Redis, and that's fine. But this can lead to dangerous operations like flush, flush DB, flush all, etc., etc. But if you have some kind of proxy in between, you have 2 big advantages. You can reduce your connection overhead in a stateless language. Languages like Golang, Node.js, Java, etc., should not have this problem. Stateless languages like PHP, without an FPM, without persistent connections, can have these issues. Plus, in a bigger team, you can block expensive or dangerous commands. Means I can block in this proxy every command that has an O by N time complexity to avoid those issues again, without touching our PHP application. That's great, because there you can avoid like flush DB, etc. in production. September 2014, up to now. So after these changes, we were kind of stable with our Redis infrastructure. Of course, here and there, a few bugs and hiccups happen. 2 of them I will talk now. So Redis is an in-memory data structure store. Means Redis is bound to two components of your server. First, to your RAM, because to store your data. Second, to your CPU, because if you have a higher tick rate for your CPU, you can process way more commands per second. But back to RAM. What happens if your amount of data grows so quickly that it doesn't fit into RAM anymore? Classical answer in IT, it depends. This can happen. This was a screenshot from April from one of our applications. And there the out-of-memory killer from the operating system comes around. The point was, Redis was configured to use more memory than the server has installed at all. And in those cases, the out-of-memory killer of the operating system will evaluate, okay, I'm swapping memory to disk. Which process consumes as much memory? And this will be killed. Sadly, it was our Redis. Another alternative that can happen is your application just stopped working. For example, when you log into our services, we have an OAuth server, and we store the tokens in the Redis. But the problem is, if your Redis is full and say, I don't accept any more keys, you can't log in anymore. To avoid this, Redis has some kind of eviction policy. So with eviction policies, you just say, what should happen when my Redis instance is at maximum at the capacity? No eviction is a typical thing I told you a second ago, like, okay, return an error when the memory limit was reached. Of course, you can apply a few intelligent algorithms like, please delete all keys that hasn't time to live and that was less recently used. I mean, you can do smart things as well, like all keys random, evict random keys. It's possible. I never saw this before. So review your runtime requirements. Plan your maximum memory limit and set the right max memory policy. Otherwise, you will have a bad time. On the other side, again, this question, what happens if your amount of data grows so quickly and it doesn't fit into RAM anymore? It depends, because maybe you need all this data. Maybe you just want to throw it away. Maybe the eviction policies don't fit for you. For these kind of things, you can use algorithms that are typical in the NoSQL world. This one is consistent hashing, means you have a key and a value, and this key will be hashed by an hash algorithm, whatever, MD5, Moore, etc., etc. And according to the result of the hashing operation, it will be assigned to one server. So you consider a number of servers as a ring, and your data is sharded over several nodes. What does it mean if you use Redis as a main cache? No problem. If one of the nodes fails, you only lose n% of the cache instead of 100% of the cache. This can be done by this is a typical pattern that is run for memcache as well. So plan your capacity and use it. Shard your data over multiple machines to store more and be resilient to failure. If you have Redis in production, there are way more topics you should care about, like replication, monitoring, security model, etc., etc. This talk will go far more when we would cover all these details. I've written an article about this talk, about our experience, with a little bit more details in our blog. And we were kind of lucky because in March, someone posted it on Hacker News. And it was on the front page for a few hours, and a few comments come along. So someone who's named B. Tilly said, Redis is it's a very sharp knife. It is perfect for some problems and horrible fit for others. And the creator of Redis, Anti-Res, posted, one problem with Redis is that it looks superficial, simple, but actually like a tool used in a critical context. There are two possibilities. First, know how it works very well and do great things with it. Second, don't understand it properly and find yourself in a big trouble sooner or later. In my opinion, this quote describes exactly what we did. We didn't understand this. The complete story was not the fault by Redis. The complete story was our fault. We had design and concept issues. We didn't know how we use Redis properly, like described in this. If you use Redis in production, if you plan to use Redis in production, if you have issues with Redis in production, check these things. I hope you will not have a terrible time like we do. We had a few hard months. We learned tons of stuff. We didn't stop to optimize our Redis stack. Since this story, we hadn't faced serious issues and have a lot of fun with this wonderful database. So I hope you had a few points that you can apply to your daily work or maybe to future projects. So thank you.
Thank you, Andy. Very technical talk. Do we have any questions? Some of you mentioned that are working with Redis. They have Redis in production. Does this look familiar? Did you experience the same kind of issues?
Hello. So thank you very much for the talk. It was very informative and really interesting. And by no means am I any database expert, but what separates Redis from other NoSQL databases like Mongo, for example?
To compare Redis with Mongo is kind of tricky. I'm not really familiar with Mongo. I never used it, to be honest. What I know is that you can apply, for example, different kind of operations. Like in Mongo, you can write map and reduce actions with JavaScript, as far as I know. And it's more, it's a complete different way of thinking, because Mongo isn't, as far as I know, document store, right? So you don't have to apply a structure. In Redis, it is not as a document store. You can't store natively a bunch of JSON in it and query accepted fields. You can use a hash map. It's a complete different way of designing your applications. In Redis, you have to be really careful to know your access patterns, and according to your access patterns, how you read your data, design your data structures. I don't know if you can apply relations in Mongo, but in Redis you can't completely. You have just keys and values in there, and the values can be strings like hash maps, etc., etc. So in my opinion, those two systems are not really comparable. So because they are completely, have a different background and a different use case.
Okay.
Hi, thank you for the talk.
Hi.
So the question is, now all problems more or less are solved as you described. My question is, at this point, are you thinking about moving to some other in-memory data store, or are you at the point where you've obviously learned a lot from this process, so you're...
The question is if we consider to move to a different data store?
Yeah. I mean, you had lots of problems. Obviously, this is not something to consider while you're at the point of solving these problems. But
we are running Redis and Memcache in production.
Until you did.
And yes, it was a thought to switch during this journey to Memcache, etc. But on the other point, Memcache has issues as well, right? When it comes to the slab allocation of memory, sizes, etc., etc. So back in the days, we said we should fix this problem, otherwise we have to rewrite a big bunch of code. And this will take way more time, and then we had the risk that we run into issues in Memcache as well. So we had this thought, but we threw it away quite fast.
You have to be.
I'm here today, the complete day, and tomorrow, so I would love to chat with you about those kind of topics. If you have questions, feel free to tweet me and provide me positive, negative feedback at all. I'm open for everything. So thanks for having me.